T-34 is a Soviet medium tank of the Great Patriotic War period. The most massive tank of the Second World War and the post-war period. Developed by the Design Bureau of the Tank Department of the Kharkov Plant No. 183 under the leadership of Mikhail Ilyich Koshkin. The success of the project was predetermined by the use of the latest highly economical V2 diesel engine, thanks to which the tank has a high specific power, the ratio of engine power to combat weight. T-34 has a classic layout. The crew of the tank consists of 4 people, a driver and a gunner radio operator, located in the control compartment and loading with a commander, who also performs the functions of a gunner, who were in a double tower. The armored body of the T-34 is welded, assembled from rolled plates of homogeneous steel armor of grade 8C of high hardness, with a thickness of 13, 16, 40, and 45 mm. The armor protection of the tank is projectile-proof, of equal strength, made with rational angles of inclination. Tower T-34, double, close to hexagonal in terms of shape, with a stern niche. Depending on the manufacturer and the year of manufacture, turrets of various designs could be installed on the tank, a welded turret made of rolled plates and sheets, a cast turret, a stamped turret. Since 1942, they switched to the production of an improved turret, which was distinguished by a larger width, a smaller inclination of the sides and stern, and a plan shape close to a regular hexagon. The new tower was distinguished by a slightly larger internal volume, but still remained cramped and still double. In 1943, a cylindrical commander's cupola was introduced, which was mounted on the roof of the tower. However, since the tank commander was busy servicing the gun, the turret turned out to be practically useless for him and was not widely used. The main armament of the T-34 of early releases, 1940, early 1941, was a 76 mm gun of the 1938 and 1939 model or L11. The length of the gun barrel is 30.5 calibers or 2,324 mm. The initial speed of the armor-piercing projectile is 612 meters per second. From March 1941, it was replaced by a 76 mm gun of the 1940 model or F-34. The barrel length of this gun was 41.5 calibers or 3,162 mm, and the initial velocity of the armor-piercing projectile was 662 meters per second. The advantage of the F-34 over foreign counterparts was the almost complete compatibility of the used ammunition with towed artillery pieces of the same caliber, which made it possible to have a much larger range of ammunition. The gun was installed in the frontal part of the tower, in a mount with a machine gun. Vertical aiming within 5 to plus 26 degrees was carried out using a screw mechanism, horizontal aiming, exclusively by turning the tower. Since 1943, a side level was also installed on the 76 mm cannon of the 1940 model for firing from closed positions. For aiming at the target, a telescopic sight and a periscope panoramic sight were used. The gunner radio operator could use the diopter sight of the course machine gun to view the terrain, which had a field of view of only 2 to 3 degrees. The commander's panorama PTK on a significant part of the tanks of later releases was replaced by the PT-4-7 periscope sight, which can also be used in a rotary mode for observing the terrain and provides a field of view of 26 degrees at a magnification of 2.5 times. One range of ammunition was used for the gun, unitary shots. The ammunition load of the gun on the T-34 produced in 1940 to 1942 consisted of 77 shots, placed in suitcases on the floor of the fighting compartment and in stacks on its walls. On the T-34 produced in 1942 to 1944 with an improved turret, the ammunition load was increased to 100 rounds. The ammunition could include shots with caliber and subcaliber armor-piercing, high-explosive fragmentation, shrapnel, and grape-shot shells. The vast majority of foreign tanks were armed with cannons of no more than 50 mm caliber, which were significantly inferior to the 76.2 mm gun in the power of a high-explosive fragmentation projectile. The first effective means of combating the T-34 was the 75mm PaK-40 anti-tank gun, which appeared by the spring of 1942, and the 75mm KWK-40 tank gun with a barrel length of 43 caliber. However, their small number prevented the successful fight against the T-34. According to the secret report of NII-48 dated 1942, the frontal armor of German tanks was confidently penetrated by 76.2mm projectiles at almost any distance, including within plus or minus 45-degree heading angles. The auxiliary armament of the T-34 tank was two 7.62mm DT machine guns. One of them, paired, was placed in an installation paired with a gun and had common pointing angles with it. The other, course, was in a ball mount in the upper frontal plate of the hull. Its aiming angles were plus or minus 12 degrees in the horizontal plane and minus 6 to plus 16 degrees in the vertical. According to various sources, the ammunition load of machine guns on tanks of early releases was 46 or 49 discs of 63 rounds, 2,898 or 3,087 rounds in total. On the earliest vehicles that did not have a radio station, it increased to 75 discs, 4,725 rounds. On the T-34 with an improved turret, the ammunition load consisted of 50 discs, 3,150 rounds. On the T-34 of the first series, a shortwave telephone radio station 71TK3 was installed, which was soon replaced by a newer 9R. The 9R radio station provided a communication range of 15 to 25 kilometers from a stop and 9 to 18 kilometers on the move in telephone mode. Since 1943, T-34s were equipped with the 9RM radio station, in which information was transmitted in only one direction. On tanks of early releases, due to the lack of radio stations, they were equipped only with the vehicles of unit commanders and only a small part of line tanks. In the future, the situation with the release of radio stations gradually improved, but finally they were able to switch to full radio equipment of tanks only during the release of the T-34-85. For internal communication between crew members, a telephone tank intercom was used. On tanks of early releases, TPU-2 or TPU-3, later replaced by TPU-3 bis F. All modifications of the T-34 were equipped with a V234 V-shaped 12-cylinder, 4-stroke, high-speed liquid-cooled diesel engine with fuel jet and twin-shaft distribution mechanism, DOHC, developed under the leadership of Konstantin Fedorovich Chulpan. The V2 engine was originally developed for aviation applications. Due to the shortage of V2 engines, 943 tanks were equipped with M17T or M17F carburetor aircraft engines up to 500 HP. In addition, in the manual tank T-34 in battle in the characteristics of the tank, a V2K diesel engine is indicated, 400 HP at 1700 RPM. The maximum power of the V234 engine is 500 HP at 1800 RPM. Engine capacity, 38,880 cubic centimeters. The weight of the complete engine is about 1,000 kilograms. The engine resource before the first repair is 50 hours. To clean the air entering the engine, an air cleaner of the Poman and Cyclone types was used, which significantly increased the reliability of the propulsion system. The exhaust system of the engine is straight through, there are no mufflers. Consists of two exhaust pipes in the stern of the tank. The 4-speed gearbox required a lot of physical effort from the driver and did not differ in reliability, therefore, from the end of 1942, a new 5-speed gearbox with constant gear engagement began to be installed on the T-34, and the design of the main clutch was also improved. An MB-20A electric motor is installed to rotate the tank turret. The motor consumes different current strength depending on the tank tilt, from 90A in a horizontal position to 200A or more when the tank is tilted. The maximum tilt angle of the tank, at which the motor still rotates the turret, is in the range of 17 to 22 degrees. The chassis of the T-34 used a candle suspension, or as it is also called the Christie suspension. Later the suspension was upgraded and the spring was placed at a slight angle. Caterpillar's T-34, steel, ridge engagement, consisting of alternating ridge and flat tracks. To improve patency, lugs, spurs, of various designs could be installed on the tracks, bolted to every fourth or sixth track. Until the autumn of 1941, T-34s sent to the front from factories in small quantities did not cause the Germans particularly serious problems. In addition, the reasons for the low efficiency and high losses of the T-34 in 1941 are the poor mastery of new tanks by personnel, the tactically illiterate use of tanks, shortage of armor-piercing shells, design flaws in poorly developed vehicles in serial production, lack of repair and evacuation equipment and rapid movement of the front line, which forced the abandonment of out-of-service, but reparable tanks, the haste to bring mechanized formations into battle without prior organization of interaction with other branches of the military. Poor management within the tank formations themselves, the lack of support from aviation led to significant losses, the poor technical condition of the running gear of the old fleet, T-26 and BT, and others. However, the German tanks were almost powerless against the larger numbers of T-34s and KVs. Due to the combination of its combat qualities, the T-34 was recognized by many specialists and military experts as one of the best tanks of World War II. During its creation, Soviet designers managed to find the optimal ratio between the main combat, tactical, protective, operational, running and technological characteristics.